Now we're going to go through an example of reading box plots, specifically side-by-side box plots. So these box plots show the test scores for two different biology classes and the students in those classes. So class A on this box plot is actually the lower class, and class B is the class above, and they're also labeled over here. So which class had a higher median score? So if we recall from when we drew the box plots, the median is the line in the middle. So based on the location of the middle line, class B has the higher median score. Which class has the larger minimum score? So looking at our box plot, we can see here class A has a minimum of 60. And while it looks like class B has a minimum of 70, we actually need to be really careful not to overlook the little dot over on the far left, which indicates that the minimum score is actually below 60, roughly 55, and it was in fact an outlier. So because of that outlier for the minimum, this means that class A has the larger minimum. Which class has the larger IQR? So the IQR is the difference between Q3, which would be this line, and Q1, which would be this line. And then on this graph, that would be here. Oh, that's still really hard to see. Let me do a darker color. That would be here and here. So if they're really close, you can do approximate calculations to figure out which class has the larger IQR. However, in this case, it is pretty clear to see that class A, again, has the larger IQR. It has a much wider range on that middle 50% compared to the middle 50% on class B. And then what percent of students in each class scored above a 70? So a 70 is this line here. So on class A, that is falling at roughly Q1, which would mean the percent above that, so that's everything to the right, would be 75% of the students. If you recall, when we found the quartiles, we split the data set up into fourths, with each fourth representing 25% of the data. So that means on our box plot, each one of these sections is 25% of the data. So because 70 is about where Q1 is on this graph, that would be roughly 75% of the students. And then for class B, 70 is not the minimum, but the next smallest value. So for class B, this one's a little bit harder. It is the next smallest value that is not, so it's almost 100%. We cannot say for certain what percent it is because we don't know how many students scored a 55 or 57, whatever that is. But we do know that it's almost all of the chunks. If we didn't have that outlier, it would be 100% of the students. But because we do have this outlier, we know that there's at least one student that did not score a 70, so it's almost 100%, but not quite. So that is just a quick example of how we can read these box plots with an example data set.